at or below. Are you lost, Cummings? Yeah, back in 1-2. Notes 2. Is our packet like goofy or something? No, you're missing a huge chunk. It's just not in the notes. Alright, so count is how many, frequency is percent, or relative frequency is percent, and then percentile is percent that is at or below you. So when you guys get like your SAT scores back, or you got it back, or I think everyone in here. Are there any sophomores in here? I guess how many juniors? So you get your SAT or your PSAT back. It gives you a percentile, right? Like you're in the 85th percentile. That means you are tied or above 85% of the people. If you're in the 100%, 100 percentile, you're above everybody. If you're in the second percentile, you're better than 2% of the people that took the test. So percentile is percent that is below you, tied or below you. So how they give you relative frequency is the percentage. So there are 46 presidents in this. So the relative frequency here would be whatever 2 divided by 46 is, and then turn that into a percentage. So that's 4.3%. And then we're just going to repeat that for that whole top row. So there's 7. The frequency in this section is 7. The relative frequency is 7 divided by 46, which gives us whatever percentage, so 15.2%. So let's go ahead and fill in that row. Do we see what I'm doing? I'm getting the numbers. So if you were to add these up and check, you might not get 100% exactly because we rounded along the way. At least I did. Can you guys see this clearly in the back? Is it fine? Like Jackson, you see the board okay? It's like pushed forward more than my old one, so I don't have a good angle, so it's hard to tell. Okay, and then cumulative relative frequency is going to be the percentage that is in this bucket or a bucket lower. So right here, this is going to be the percentage of presidents that are between 40 and 45 or less. So in this case, it's just the 4.3%. Then as I go to the next one, I start to build. So what goes here is the percent of presidents that were between 45 and 50 or younger. So you're going to take these two percentages and add them up. So that's 19.5%. So you're like accumulating as you go. Like, okay, 4.3% are 40 to 45. Well, if I jump to the next level, now I've captured 19%. And then every level I go, I'll just keep adding and adding. And when I get to the end, this will be off a little bit because of rounding, but what should this be? It should be 100%. this third one here, so now it's 28.2% are in this slot, but the cumulative relative frequency is going to be 28.2% plus that, or you could do 28.2% plus this because this is already like representing those two things. So 47.7%, and then you just keep adding. So this number here will be 47.7 plus that 26.1. So what's that? 73.8. And 95.5, 97.6, and then I get to 99.8. So I'm off a little bit because of rounding. I didn't really pay attention to the rounding. So this is a weird thing about the AP. I go to a seminar, this is 20 years ago, like, because I didn't teach this right away. I taught it like 5 or so years into my career. They're going through this, and someone asks, like, what do you round to on the AP stats test? Let me back up. On the AP Calc test, they say very specifically round to 3 digits every single time, no matter what. Or don't round. Like, that's your choice. On stats, someone said what do we round to, and their answer was round to where it makes sense to you. And I'm like, what does that mean? Like, what if what makes sense to me is different than what makes sense to you? And they're like, well, we want you to round to where. So if you're in doubt, put more decimals. You're not going to get in trouble for like not rounding. I'm sometimes afraid to round too much because they're very vague about like how to do that. So just keep that in mind. Question on how I'm getting these numbers though? Alright, turn the page, we're gonna graph them, and I apologize, it's on like back and forth pages. We can fill this thing in first. So we got 4.3% here. 19.5. 7, and 99. So we're going to make a relative cumulative frequency graph. Stage where you can have a naked graph. Label everything you're putting on there. What I'm graphing on the sides is the percentages. The cumulative percentage that we just calculated. Then we need an overall title, so I'll just throw like presidents up there. Just something. I have skipped something on this graph that should be there. It's a little bit inaccurate right now. Anybody tell me what? I got 3 labels. 1, 2, 3. We talked about that like last week, right? So I just jumped from 0 to 40 and then I started going by 5s. I can't really do that unless I indicate like, hey, I skipped a bunch of crap right here. So you just put like, I don't know if that was clear, but you put like this little wiggle. And that indicates like there's a bunch of stuff here. I just kind of like hit it. And we're jumping to the part that we see. And then we're going to graph our points. So between 40 and 45, well at 40, let's start at 40. What percent of presidents are 40 or younger? the time I get to 55, I've got 47.7% of the data. Again, you're eyeballing it. I've actually never seen them have you make one of these on the AP test. Not that they couldn't, but usually it's interpret. But I think making it helps you learn to interpret, but I don't think you'll have to make one. What are we at? 55. So 60, 73.8%. So there. 65 is 89%. Could this graph ever reverse and start going down? Like, can I start having lower percents? Could not, 'cause I'm just adding percents. Could it go straight across? Yeah. It could be up and then flat and then up again. It just can't ever go down. And then, so 70 is 95.5. These are going to get pretty hard to do accurately. But 75 is a little bigger than that, 97.7. And then 80 is a little bigger than that, 99.8. Then you would connect this. So you should be able to read this two ways, like back and forth. I should be able to tell you the age of a president, and you tell me like what percentile they're in, or I tell you the percentile and you tell me the age of the president. So very commonly that would look like, they wouldn't say like, oh maybe, but let's say let's find the median. The median is halfway, so that's the 50th percentile. So if I said find the median, you go to the 50th percentile, go across, go down, and it's really hard because we're just kind of making up numbers here, but somewhere around there, like 55. Don't worry about the actual numbers, just realize how I'm doing it. Or I could say, if you are 50 years old, what percent, or 50 years old or younger, what percentile is that? What percentile is the age 50? Then you go to 50, go up, you'd say like 20%. So try to answer those two questions at the bottom. That's just like going through what I just said, just back and forth. This part here, what does this mean in the context of the problem? That's huge. You have to give it the context of the problem. For example, if you just said 30th percentile, if you just said like 54 and stopped, the math is right, you read the graph right, but you gotta tell them what that means. So like 30% of the presidents are below age whatever. So approximately what age is the 30th percentile? So I go to 30. That's maybe like 53. What does that mean in the context of the problem? 30% of presidents were 53 or younger. And if you are asked to interpret this, it'll be way easier to read. There'll be like lines and an actual accurate graph instead of like my stupid sketch of it. All right, then the other way around. So Richard Nixon was the 37th president, which doesn't mean anything. I don't really care about that. And was 56 years old. What percentile is this? So 56 is around there. So I'm going to go up as best I can on my sketch here. And that's maybe around the 50th percentile. 60th percentile? It's hard to tell. Don't get caught up in the actual numbers, but it makes sense what I'm doing to read it. Okay. Let's say it's 50 percentile. So that'd be the 50th percentile. And that means 50% presidents were 56 or younger. And if you want to get fancy and say when they got inaugurated, that's better. That's probably not necessary. Questions on anything I just did? How to read one, how to make one, read it back and forth, anything. Alright, I'm gonna have you guys make one on the next page. We're gonna play a little game first. The next page is blank, right? Like the back. It was blank. Did you use up both sides of it? Find some place to write. Stop. No, go away. Okay, stand up. I'm gonna roll the die. You get to whatever the die says. That's your score, and then you just you add up every time we go. So if you roll a 4, you got 4 points. If I roll again and it's a 5, you got 9 points. If I roll it again and it's a 3, now you got 12 points. If I roll a 6, you go to 0 and you're out and you sit down. So you gotta kind of decide: am I good? Do I want to keep pressing forward and try to get more? All right, ready? And then you like keep track of, write down your points. Yeah. So right now everyone's in. Right now, everyone has 1 point. You could sit right now. Be like, I think that's as high as I'm going to get. Because if I roll a 6, you're down to 0 points and you're out of the game. Does that make sense? All right. So now you got 6 points. Everybody sticking? Everybody sitting? Beck, are you sitting? You said it 1. Okay. We got 10 now. Keep going. Go one more time to the side. 5. We're at 15. Keep it rolling. Wait. Did anybody sit down after that one? Just a couple? Okay. I think I would have sat right there. Here we go. Is that 20? Alright, we got a few opting out at 20. Ready? 21. Still rocking? 26. Wait, whoa, hold on. What is that? Okay, thank you. So let's talk about this real quick about probability while you're standing. I understand. Probability is like how much things happen over the long run, right? So, like a coin is 50-50, but if I flip, this was an actual question on the AP test a few years ago. I flip a fair coin 100 times and I get heads every single time. How many heads would you expect in the next 10 flips? 5. If it's a fair coin, what happened before has nothing to do with it. The coin doesn't remember, like, oh, I was heads and heads and heads, so I better like catch up and be tails soon. So, like what he was saying, I know you're joking, but like it hasn't been a 6 yet, so why would it? Well, how often would you expect it to be a 6? 1 out of every 6 times. But does that mean like every 6th time it's going to be a 6? No, it's just like over the long run. You could go like 100 times without getting a 6. You could get 3 6s in a row. So what are we at? 20, 21, 26? All right, here we go. All right, come write your scores on the board. Large so everyone can see them. Preferably preferably in like a list.
20 million. Nolan, can you write one?
Write it big.
Thanks.
What if I lose all my points? All I can do is like So you're going to make a relative cumulative frequency. We're going to go like by fives. 0, 5, 10, 15, 20. Highs was 26. You'll notice I abbreviated 2 of those words in relative cumulative frequency, but be careful about abbreviating that middle word. What do we call this game? Dice game. Dice gambling. Many people are in the class. You guys know these yet? $25? That's a nice friendly number. No, I understand it's a serious question, but like not only are you off topic, but you raised your hand. I try not to listen to you like at all. But when you raise your hand, definitely picked them all like 10 years ago before school. I don't understand how pickleballs for old people. It's like, 16%. That should be right there. What's wrong? So by the time I get to 0, I've got 4 scores. By the time I get to 5, I've only got 1 more score, so I've got 5 scores. By the time I get to 10, I add 2 more, so I've got 7 scores. And then this is like 4 out of 25, which is 16%. This is 5 out of 25, which is 20%. 7 out of 25, which is 28%. Does that help you get started? Kind of starts off like that. Does that make sense what I'm doing? Questions? You guys' faces don't look like it makes sense. Your face does. Oh, the confusion is not the issue. It's like just counting. You multiply 25 by 4 is 100, right? So like multiplying like 10 by 4 is 40%. If only there were other places to sit. And 17 what? I messed up somewhere though. Is 11 wrong? So 7 that are 10 or below. So then I'm counting 15 or below, right? So that's 1 more, 2 more, 3 more, 4 more. Alright, so 20s. So 1 more, 2 more, 3 more, 4 more, 5 more, 6 more. This is okay, so this is 17. Do people agree with 17? And then 25. 1, 2, 3. 20. And then there were 5 26s. Okay. So 15 is 44%. Because This is out of 25 people in the class. You okay? But not that one. So 20 is 68%, so around there. 25 is 80%. And then 30 is 100%. So it should look something like that. And then I want you to try to estimate these things. Let's do these. What would you like me to do? Turn invisible? Yelling at me for like. That's separate issue. I thought you were yelling at me for not being invisible. I'm trying to answer those 4 questions. Do you move forward? Alright, 75th percentile. So you would go over here to 75. Oh, wow. Read across, and maybe 21. Right. I mean, this is like you're never going to be asked to. No one's going to look at you and be like, well, I got 20.7. You're wrong. Like, close to 21, 20, 22, somewhere around there. The median, what percentile is that? Median's right in the middle. That's 50th percentile. So you go to the middle. So maybe like 16-ish. 25th percentile. So I'm down here. Probably like 9. 10 is 28th percentile, so it's a little less. And then part D is going backwards. So 12 points is what percentile, so 12 is here, go up and read across, and maybe that's like 35th percentile or something. And again, don't get caught up in the actual number, but are there questions about how I'm reading it? Okay. Turn the page in your notes. we're gonna start unit 3, but not. We're not gonna finish. Okay. Describe the distribution. So you will get a graph, a histogram, a dot plot, a stub and leaf, one of the ones we just did, whatever. And they'll say describe the data. And they're looking for four very specific things. This acronym helps you. So we're looking for shapes, outliers, center, and spread. So the next thing we're gonna do is like kind of dive into each of those 4 things. So how would you describe shape? How would you describe outliers? We did check the calculators out last time, right? So make sure you bring those tomorrow because we'll start doing stuff. We'll start using it. Okay, so first thing is shape. So we get these different options for shape. Unimodal. So mode, what does mode mean? Most frequently used one. So unimodal means I have like one number or one area that is more common than others. So it could look like this. It could look like that. But you've got like one hump. Like most of the data is here. Most of the data is here. Then you got some other stuff. Bimodal. So there's 2 things that happen the most. So it's like 2 humps, like a camel. So like this, or if you had a histogram, maybe something like this, where you get like these 2 humps. So this is 1 hump. This is 2 humps. Uniform means all heights are approximately the same. So if you had a histogram and it was like every bar was like pretty darn near the same, or exactly the same. Something like this. Symmetric just means it's the same if you like flip it over a line in the middle, like a mirror. So the very common graph we use in here is like a normal curve. That is symmetric for sure. But that's not the only thing that's symmetric. Something like that would be symmetric because it's the same on both sides. So like a bimodal where there's a line down the middle, or a uniform is symmetric. So if I have something like this, those are all the same, so I can draw a line down the middle. It just means it mirrors itself. Symmetric is a mirror. And then left skewed and right skewed. So left skewed means left tail. So left skewed looks like this. Where most of your data is over here. But then, so this is like how, if I were to give a test in, not necessarily an AP, but in regular geometry, this is how the tests come out. I get a few people that got 100. Most people get like between 70 and 80. But then I'm going to get a couple that get like a 10. So that's this tail. That's going to drag the class average down, but it's not really representative of how like everyone did. Right skewed is the opposite, so right skewed, right tail. We'll get into more of this tomorrow. Would look like that. This is like income in the United States. So there's people that make darn near nothing. This is kind of like lower middle class, upper middle class. Then over here you got like Bezos and Gates that are going to pull the average up. It doesn't really represent like what the median person is making. Right? Let's just do this now before we. I'm pretty sure it comes up again, but just in case. No, it has to. But anyways, so this one, the mean is less than the median. So the average is dragged want you to draw this in your head, but like I want you to think about or draw if you're confident a symmetric bimodal and then a unimodal right skew. And it can be like a histogram like this type of thing, or you could do like the curve, whichever. If you're not sure, draw in your head and wait till I confirm it. If you're confident right now. So symmetric bimodal, you might have done like that. That would be symmetric bimodal. You could do like something like that. That's still symmetric bimodal. That would still flip over itself. It's still got two humps. You could have done a histogram maybe and gone like two humps. Any of those are fine. Unimodal right skewed. Right skewed means right tail, so you got like most of the data here, but then you got like some crazy outlier over here. It's gonna pull the data that way. On a histogram, that would look like most of your data's here, and